This type of problem is a problem where the object is launched at an angle, not horizontally. So the velocity in the initial situation is both in the x direction and in the y direction. So if we look at this one and draw a picture, a shell is fired from the ground with a velocity or a speed of 1.7 times 10 to the third meters per second. The formatting kind of got weird there. And at an angle to the ground of 55 degrees. We are supposed to ignore air resistance and find the shell's horizontal range. So the shell is going to fly through the air, and we are going to find the displacement in x, and then the amount of time the shell is in the air. So in order to do this, we need to gather our variables in the x and y dimensions. If you are confused and you don't know what else to do, one thing you always can do is resolve a vector that is at an angle. So if I have a hypotenuse and an angle, I can get the x and y components. And so when I do that, I get sine of 55 is the y component, or the velocity in y, over the hypotenuse, 1.7 times 10 to the third. That component, when you calculate, should be 1393. The x component can be found with the cosine. So velocity in x is 1 over 1.7 times 10 to the third, and the velocity in x ends up being 975. Keep at least the number of sig figs that the problem has, or more. This ends up being 975.07, so if you want to keep a couple more, that's fine. What we just got then is the velocity in x to start, and because there is no acceleration in the x, that will be the velocity in x everywhere in the flight, 975.07 meters per second, and velocity in y to start is 1393. Fix that a little bit. 1393. Okay, and that's also in meters per second. This velocity will be changing because we have acceleration in the y dimension to be negative 9.81 meters per second squared. And that's the only information we are given. We need to find the horizontal range, or the distance. And again, I look at the x dimension to do that, and the only equation I can use is distance divided by time, because there is no acceleration in the x direction. If I want to try to use that equation right now, I can't, because I don't have time and I don't have displacement in x. So that's not going to work. So I need to focus on the y dimension. And I'm given two pieces of information here. I'm not given a displacement in y, although the displacement in y overall is 0. I'm just given the initial. However, if I choose a specific point in the flight, because this object is going to start on the ground and end on the ground, I can say the velocity at that point, at the peak, is 0. And that gives me another variable to work with. So with that information, I can use my equation that has acceleration is v final minus v initial over time, and it allows me to solve for time. So my acceleration is negative 9.81. My final velocity at the peak is 0. My initial velocity was 1393 in the y dimension. Make sure we're only using y variables, divided by time. When I solve, I get a time of 141.997 seconds. However, that's the time just to get to the peak. So if I want the whole time, the whole flight time, I can multiply that by 2 and get a total flight time of 283.99 seconds, which is really answering question B with sig figs. That would be 284 seconds. I can take that time then, and now I can work in the x dimension and solve for the displacement. If my velocity in x is 975.07 and my time is 283.99, and I can solve for displacement in x, I will get a displacement in x of 2.77 with 3 sig figs times 10 to the 5th meters.